Welcome. In this video I'm going to show you how you can obtain Hodges-Lehmann estimate for a one sample scenario using R. I'm currently actually using R version 4.3 as you can see, and only the basic packages are loaded. I'm using Jupyter Lab with an R kernel, but the R code should also work in, for example, R Studio. The Hodges-Lehmann estimate for one sample is actually the median of the Walsh averages, and the Walsh averages is taking every possible pair and taking the average of the two values that you put in that pair. To show you how this can be obtained, we load in some example data. So from the student statistics file, which contains responses from students on a survey, I actually already loaded these. I don't need all its data, just an ordinal field, so I'm selecting Teach Motivate, which was how motivated the students felt the teacher was, or how motivating the teacher was. And the frequencies are stored, obtained by using a table on that ordinal field. So for example, you can see that 20 students fully disagreed. In another video, we also need the coding, which is just the possible categories in order. In another video, I show you how you can do this with my own library that actually has a function specifically for this, MA Hodges-Lehmann. You just need to feed it the data. But in this video, I'll show you how you can do it without libraries, or there's another library from DeskTools or Stats that could actually be used. They do not allow for any missing values, so let's remove those. And we might actually need the length of the sample size. So let's get that as well. And then we can actually replace all the values with a number by using the replace function, and use numeric to make sure it's actually numeric. So here I'm actually replacing all the values with the appropriate number, and then actually convert all of them to truly being numeric, so that now my data is no longer fully disagree, agree, etc., but just a number. To use DeskTools, I need to of course install it, and then I can actually load it. And then I can use Hodges-Lehmann, and that should return me the Hodges-Lehmann estimate. It's the same result as running a Wilcoxon test and setting the confidence interval to true. And also setting exact to false, and then taking the estimate. So then you're actually just getting the pseudo median of 4.9999. It's a small difference, and that's because of with my own library, but there's a long discussion about that difference if you're interested by clicking on that link. If you don't actually want to use any library, you can actually remove all the missing values, of course, by using NA omit. You're still using the stats library, but that comes with R, so I'm not counting that one. The length is of course needed, so we can just use the length function, replace and convert as shown earlier. And then we can finally do that Walsh averages. So, and then take the median to get the Hodges-Lehmann estimate. So take all possible values, pairs, calculate the average. So we're doing that over here. And once we have all those Walsh averages, I'm running over all of them every time calculating the average. I can then calculate the median of those, and in this case that's 2.5. Alright, if you like, we can actually make use of the outer function, so by actually making the whole table and then use the outer function to actually do it similarly for the Walsh, and then take the median of those, and then you also get 2.5. Alright, I hope this video was somewhat helpful, and thank you for watching.